You are all welcome to today's session of the boot camp, and we'll be continuing from where we stopped yesterday. The previous class. So in the previous class, we talked about testing. We talked about uh, everything you need to know about testing, and we also did some hands-on session on how to write tests for your Cairo programs. So today we'll be looking at Starknet Foundry and how you can use Starknet Foundry to run tests for, and how you can use Starknet Foundry to run tests for your Starknet contract. So I'll be starting right away. Similar to the last class, we'll be using CodeSpace, GitHub CodeSpace as well. So to have everyone start on the same ground. So I'm just going to open up CodeSpace real quick. But before then, let me share my screen. Okay, I believe you guys can see my screen. You can just indicate with a reaction if you can see my screen. Okay, thank you. So this is a blank code space, and installing the necessary packages that are required to use Starknet Foundry. So before that, let me just quickly change the theme of this code space to something that's more convenient to my eyes. Okay, I don't know why that is not changing. Probably should be network problems. Let's try that once again. Okay, perfect. Okay, so the first thing we'll be doing is to install Starknet Foundry. So I have my notes here, and the guides are there to install it. So I believe from the last class, we must have installed Scarb in our code space. So I'm just going to do that again because this is a new code space, and none of those stuffs have been installed in it. So Scarb is installed, and let me check that. The next thing after installing Scarb is to install Rust, because you need Rust in order to use Starknet Foundry. So this is the command to install Rust. I'm just going to copy that and paste it in my code space. And I select the standard installation. So this is going to take some time depending on maybe your network or the device you're using, but I'm hoping mine complete. Okay, yeah, perfect, it's done. So Rust is installed. This is the confirmation message and verifies that Rust is installed successfully. So from the guide, the next step is to install the Starknet Foundry toolchain installer. So if I copy the command and paste it over here, And as you can see, the tool chain installer was successfully installed, and the guide here is asking me to run the command sn foundry up. So running sn foundry up will install both sn forge and sn cast right in my terminal. So in order to verify if they were installed successfully, these are the commands to run: sncast or sncast dash dash version or snforge dash dash version. So as you can see, I have sncast installed, and then that was the typo. So you can also see that I have snforge installed successfully. So we're just going to move on to the next step. Now, in order to create a new Foundry project, you can run the command. But before running the command to create a new project, you can always use the command, the dash. You can always use the dash dash help command, right? And this will list all of the available commands for you. So over here, you can see the test command. It's used to run a test. Used to run the test for a project. And the init command is used to create a new directory. So that's what we want to do now. We want to create a new project. Let's call it. Well, let's use a more generic name. Let's say. So this is also going to take some time to download and install the necessary packages. So we're just going to wait for some seconds for it to complete. Okay, perfect. That is done. So the next thing to do now is to move into the newly created project directory. If you run ls in your current terminal, you see that you have a folder called a project folder called Starknet. So I'm just going to move into Starknet. So I'm inside of Starknet now. Quickly understand. Now let's quickly look at the content of Starknet. You can see that there is the sm400.toml, there is the Scarb.toml. Now this Scarb.toml is similar to what we had in the last class when we were using Scarb to run the test for our Cairo project. It is very similar to this, but the few additions are the dev dependencies that are added. As you can see, sm4 std, and this is the main package we'll be using to run the test, and to write the test, the test for Starknet contract. So let me quickly open the source directory. You can see that there is a boilerplate. There is a boilerplate Starknet contract here. This is the LO contract. So when you check the tests folder, you can see test written for this Starknet contract. But before I proceed, I'm just going to install the language server so it can help syntax highlighting and make our contract look a little bit more nicer. So Cairo 1. And in case you are facing the same inconvenience of having just white and black text in your editor,
hello, sir. Please.
I didn't get that.
I said, can you zoom out? Can you zoom out, please?
Okay, I believe this should be better.
Yeah, it's
So,
okay. Thank you.
okay, so I'm gonna be installing Cairo 1.0, and this will help in coloring syntax. I think this is way better than what we had before. So yeah, this is just a very simple Starknet contract, and I think it has two functions: increase balance and get balance. So increase balance actually writes to the balance variable in storage, and get balance just simply reads that balance variable in storage. So this is the test. But I'm gonna wipe everything off. So we build our own contract from scratch and write tests for it from scratch. So I'll simply create a new file called counter.cairo. So we'll be using a counter contract to uh, to learn how to test, right? Because this is a very basic contract, and I believe we don't really need any background knowledge to understand the operations and workings of this contract. Because the one of the main challenges of testing is you have to spend enough time to understand what the contract does before you start writing tests for it. Because if you don't know how the contract works, then what are you going to test? Right, so you need to understand the contract deeply before you can start writing tests. But for the sake of this session, we are going to be using a very simple contract. So we don't, really spend time trying to understand what the contract does, because our focus is on the testing, right? So let me take away this and just import. So I'm just going to wipe whatever is in the test contract file. So I will clean slate. Okay, so this is a very simple contract. So what it does is simply increases count. The contract will have two functions. One function to increase the value of count stored in storage. Another function to get the value of count, and the third function to get the address of the contract owner. So let's jump right in and start building this contract. So the first thing we're going to do is to create an interface for this contract. And as we must have learned in the previous sessions, an interface is it's like the structure of our contract. It contains the attribute, the features of our contract. Right from the interface, you can know all of the functions that can use to interact with a particular contract. So that is what we're going to be doing to create the interface for counter contracts. So the first function is going to be increase counts. Now this function takes in an amount variable, an amount parameter, sorry, and increases the value of count by one parameter. So the second function is get count, and the life and purpose of this function is to get the value of count from storage. Okay, supposed to return the value of count, which is over here. We're taking in U32, so it's returning U32, and the last function gets owner. Okay, so turns out our contract address is not a primitive type. So in order to use contract address, we need to import it from Starknet library. So this is how to do that. So that is it. We are done with creating the interface for our contract. And the next thing to do is to create the contract itself. But before then, always remember that you can format your code. And if you feel they are messy, for instance, this code is not properly formatted, and I would like to format it before proceeding. So in order to do that, I simply run the command Scarb, and this will auto format any part of the code that is not properly formatted. So now we move on to the contracts, and we create the module, the counter module. So first thing we're going to do is to create a storage variable name counts. And owner, because we want to keep track of who the owner is. Actually, this is, so why is this company? Okay, so this contract address is actually not available in this module because we imported it outside the scope of this counter module. So in order to have access to it, we need to manually import it. Where is it? Okay, this is not supposed to be here. Yeah, we're good. So the next thing we are going to do is to create a constructor. And now this constructor takes in the address. Okay, it takes in the address of the owner and sets the owner variable to whichever address we pass in. So So what we are basically doing in this constructor function is we're taking the address of the owner and setting this owner variable in storage to whatever address was passed in to the owner. So essentially we are setting the address of the owner. So the next thing to do is to create the public functions of our contracts. We have the API embed v0. So we just created an implementation of the counter trait up here. And we're also passing contract state, the generic type of the trait. So the next thing to do now is to create the functions of this contract. So first function is increase count, and this function takes in, first of all, it takes in the contract state, attempting to change it using the ref, and secondly, it takes in an amount of field 32. So the first thing we're going to do is to verify that the amount is not invalid, because the user can enter a zero amount. So imagine increasing a value by zero. It doesn't make any sense. So we're going to add an assertion here that checks that the value is not, that the amount is not zero. So this is how we are checking that it's not zero. But this is not a good design, right? To have error messages, to have literal error messages in your code. A good design is to create a module and have all of the message, right, of your errors in a module. So you can simply import that module, import that message, and use it directly. So that's what I'm going to be doing. I'll create a test module, and I'll create an error module and have all of my error messages there. So I'm just going to call this something simple. Let's say, yeah, let's errors.cairo. And in errors.cairo, what I want to have is the module. Let's say that was 0, 252. So this is a good practice in order to have a cleaner code. So what I'm going to do is to simply import the errors module into my counter module here. So I'm going to say use. Hello Starknet is the name of my project. Okay, errors is not visible because we've not imported it in lib.cairo. Should be visible by now. So let's check. Yeah, errors, it's visible by now. Imported errors. This should be visible. Okay, let me see. Unused import. Okay, let me try to use this, but it's not supposed to be a red line. Errors. Error. Okay, I think this is having a visibility problem. Okay, must be a string literal. Okay. Problem is because of this macro. Okay, so a quick one here is this assert that I use here. You can see that the assert isn't, this is not an assert macro, it's just an assert function. And the difference between this assert function and assert macro, this is the assert macro I'm talking about, the one that has a point, the exclamation. So the difference is that this is used, right, in your code, in your contract code, but the assert macro like this is used in tests, right? So that is just the main difference. And I was using macro here instead of just using the function for test only. So I believe we are good now. So the next thing is to get the current value of count. Let's make this U32. The next thing is to, after getting the value of the current value of count, the next thing is to add whatever it is with the amount that is being uh, sent into the parameter of this function. And lastly, we update the storage variable. So this is just a very basic function that increments the value of count in storage by particular amount. So the next thing to do is to get two more functions. The first one is get count, and this get count simply returns the value of count. So the last function simply returns the contract address of the owner. So this returns a contract address. And we're just going to read the owner from storage. Okay, so yeah, correct. So the owner directory. Yeah, perfect. So this is just a very basic function. And also got twice. Okay, this. Okay, I think there is an error in this import. Okay, I think there was a typo here. Let me clean that up real quick. So this is the errors. This is, I think I need this. So let me quickly format the code. So after that, let's build this code and see, hoping that everything is good, fine. Okay, sorry, I think I don't know what happened, but okay, it's up now. I don't know what happened, but screen went off for some moments. Okay, I believe you can see the screen now. So what I did when the screen went off was to build the project, and that is what is happening at the moment. It's currently building a project, and note that this all of these processes that is happening only takes place in the first build, right? Because we are building this project for the first time. That is why it's taking a lot of time to compile the packages, the dependencies, and every other thing in this project. But subsequent builds, right, wouldn't take this much time. We do not have to compile these dependencies again because they've already been compiled and the metadata has been saved already. So we give this some time and wait for it to compile completely. Okay, so the compilation is done. And of course, the code was compiled successfully. So it means uh, there are no bugs. We didn't miss anything while writing this contract. So the next thing to do is to write the test for this basic contract we have here. And in order to do that, I'm just going to split my screen. So in order to do that, I can I'm splitting my screen so I can have access to both the code and the contract simultaneously. Okay, so in order to write the test, right, what we're going to do is to first of all create a function called tests. Create a test function. So the live run purpose of this function is to test to see if count if the increase count function works as expected. So the first thing we're going to do is to deploy this contract. And before we write the logic to deploy the contract, if you've used SMcast, right? So for the context, SMcast is so for context, SMcast is it's a CLI tool that allows you to interact with Starknet, right? It allows you to do a lot of cool stuffs, right, with Starknet right from your terminal, right? Then SMcast is provided to you by Starknet Foundry. So when you install Starknet Foundry, you automatically get access to SMForge, and SMCasts. This is okay. You also get access to SMCasts as well. So this is SMCasts. I'm not going to go through SMCasts for the sake of limited time we have on the focus of this session. But just in case you've not come across SMCast, just know that it is a CLI tool, right, for interacting with Starknet. You can use it to deploy your contracts. You can use it to view transaction receipts. You can use it to read the function for a contract. You can write to your contract using a write function. I mean, you can do a lot of other cool stuff with it. But what I want to point out here is with SMCast, right? If you want to interact with contract, you have to manually deploy it, get the address. And if you want to interact with those functions of your contract, you have to manually passing the functions and the arguments. And again, if your function arguments are not, I mean, if for instance you are using felt, you have to convert that felt, right, to a suitable type. So I mean, all of these processes are not really developer friendly. So that is the benefit of writing tests. You don't have to deploy your contract before like let's say you make a change now, you say this is, instead of amount, you say amount, let's say plus amount. So that means if you are using SMCast to test this your contract, so this little change that I just did, as mean I'm using SMCast, means I'll have to come and deploy, get the contract address, start writing commands on the terminal to use to interact with it, and to verify that this logic that I added works as expected. And it's also difficult to track, right, for other developers that I might be working with. But if I'm writing tests, I can simply just update the logic in my test, run the test, and if it works fine in the test environment, then it will definitely work when deployed to testnet or to mainnet. So that is it for the benefit of writing tests. So I'm going to continue with writing the test. And before I do that, I'm going to create a function called deploy. This is an helper function. Now, this is an helper function that helps me to deploy my contract by simply passing the name of the contract to a byte array. And after doing all of the necessary steps, after doing all of the deployments, it returns the contract address for me. But of course, I'm using contract address here. It means I have to import contract. It means I have to import contract address into this file. So let's do that right away. So the first step to this deploy function is to say contract equals. Now we need to declare the contract before deploying it, right? And in order to declare it, we can use this declare function to achieve that. But this declare function is provided to us by Starknet, the SMForge standard library. So that's what we're going to use. We're going to import the declare function from SMForge standard library. and a couple of other stuffs, contracts. So the reason why I'm importing this other traits is because when you try to deploy a contract and interact with it, a lot of stuff happen behind the scene that Starknet Foundry abstracts away from us. So by virtue of importing this contract class trait and declare result traits, this is what gives me the ability to be able to call this declare function in addition to importing the declare function. So I'm just going to pass in the name and I unwrap the result and I get the contract class. So that is it for getting the contract. The next thing to do is to construct the constructor arguments. As you can see, our constructor takes in the contract address and sets the contract address takes into the owner address. So we're going to do something now. Now, before I pass in this contract address, there's one other, good coding practice that I want to show us, right? Now, we are expected to pass in an account address, right? So that account is supposed to be the owner. Now, when you have the account address, right, and you want to create another address in this contract, in this test contract, it means you'll have to do the process manually again. You have to use a string. Let's see, owner dot try. I mean, it is not a good practice, right? It's not a good practice to have magic strings in your project, and this is a magic string. I mean, if I'm maybe contributing to your contract and I just see this magic string, I mean, it might looks weird. Like, I mean, what does this mean? What is this supposed to stand for? So what I'm going to do in this case is to create a module, account module, that every account interacting with our contracts can be created in, and those accounts will be imported from this module. So we create the first function. This will return the contract address of the contract address. So simply use owner. I mean, this can be anything of your choice, but we are using owner for purpose of clarity. So we're just going to create one extra account in order to have something that we can use in case probably you want to call the contract with another account. So let's call this account 1. one using contract address. We also add this. So that is it for our account module, and over instead of having magic SIC something now. This is we name this account. So this is this array constructor given array fixing fields. So contact address into a field. So the last thing to do is to in the constructor. This constructor similarly we unwrap with and it's able to store the because it returns a tuple that contains the first element of the tuple is the contract address, which is what we need. So I'm going to create a tuple. We're not interested in the second argument. So we return the contract address. So I'm just going to format. Okay, I think there are some errors in our code. Line 12, let's see, this is it. It should be fixed now. Okay, line 19, let me see. There's a typo in line 19. Suspecting me, semicolon. So that just formatted our code, and we have the deploy function over here. So what I'm going to do is to inside the test function, I'm going to get the contract address by deploying the counter contracts. And the next thing to do is to get an instance of that contracts. Now, before you get an instance of that contracts, I'm going to talk a little bit about dispatcher, counter dispatcher. For the for reference, we will be importing the dispatcher trait, so the counter contracts. The dispatcher and the dispatcher traits. Now, in order to get an instance of this deployed contract, we have the address already. So in order to get an instance of it, we simply call the dispatcher traits. I'm passing the contract address. But I will be coming back to it does the dispatcher. I'll be coming back to what dispatcher and dispatcher trait means. Dispatcher and dispatcher trait. I'll be coming back to explain what dispatcher and dispatcher trait means. So after getting an instance of that, let's call this counter dispatcher. So after getting an instance of that dispatcher, what we're going to do is to get initial count, because testing is simply, when you are writing tests, you are simply checking the state before an action is performed and the state after the action is performed. So the state we are keeping track of in this case is the counter. So we want to keep track of what it was before we perform the increase count action, and we also check what it will be after performing the increase count action. So let's get the initial count. Counter dispatcher dot. We are simply calling this get count function. Okay, this get count function is provided to us by the interface. So call the get count function, and we are going to start because initially we are expecting this to be the default value, which is 0. So we are going to assert that the initial value of count is 0. So after asserting that the initial value is 0, I'm going to call the increase count function. Increase count by let's say 99. Now, after calling this increase count function, which of course is a state changing function, this particular function, we're going to check for the new value. New value of count. Counter dispatcher dot get count. Now, the next thing is to assert that the current count is 99 because we increase the value of count by 99. So it is expected to be 99 because it's like saying 0 plus 99. So let's run the test. So before then, let's format it. Yeah, run Scarb. So this is the command you use to run your Starknet Foundry test. Okay, we have a couple of errors. Expected to. So the first one is line. Hi guys, can you please confirm? You can use a thumbs up or a reaction. Can you guys hear me? Okay, thank you for that. Okay, thank you. So I'm so sorry for the interruption. I think there is a district network shutdown. I don't know what happened, but I think this is a district problem. But I just switched my internet, and I believe this should serve us better. So I'm so sorry for that once again. So I'm going to be sharing my screen in a moment. Okay, I believe you guys can see my screen now. Just share my code. Okay, so I don't know why this is taking time, but I'm just going to refresh this window. So for some weird reasons, I don't know what's happening. I think this should be a problem for code space because I have a good internet connection. This was working just a while ago and no longer coming up, but I'm just gonna keep on trying. I think it's probably the fact that code space is congested. Uh, but I'm just gonna keep on trying and see if it's gonna come up anytime soon. But if it doesn't, I'll have to move this code to a local machine. I'm just gonna use my local machine to complete the code. Yeah, I think okay. In that case, I think it's a general problem then. I think it's a general problem there. I don't know. This was working fine, but let's stop talking. So what I'm going to do now is to use my local machine since this is not coming up. I'm going to copy the code and paste it in the Starknet 400 project and open it up in vscode. So just give me a few seconds to do that, and I'll be sharing my screen shortly. I don't know. Can anybody in the call try to use code space? Because I just set up the local environment in my machine, but I still need to copy the code that we've written so far. I need to copy the code into into my into the new project I just created locally. So can anybody please try to access code space and report if you are having the same problem? I'm suspecting that code space is just congested tonight. That is why it is behaving like this. But I need somebody else to verify that from the end. So anybody in the call, you can try to access code space. You let me know the output. Please, if you are trying to test code space from your end, can you indicate by maybe dropping a reaction? Uh, can you just indicate by letting me know? Okay, thank you, please. You can let me know once you're done. Okay, I think it's a general problem then. I think it's a general problem then, because from Eric, you say the code space is taking too much time to load. This is exactly the same problem I'm facing from my end here. Okay, our contract is back. So let me quickly copy this or it goes off once more. So I'm just going to replicate the same projects locally. Calculator Cairo. Paste this here. So I create errors. Okay, so let me just share what I have locally. So I believe you can see my VS Code. This is my local VS Code right now. Please drop a reaction if you can see VS Code. I mean, not this one, but this particular one, new one I just hope. It's not so clear. Okay. Just a minute. So I'll have to zoom in then. How about now, Eric? Is it clear? Can you tell me if it is still clear or not? Eric, are you still there?
Okay, yeah, it's a little bit better now.
Okay. So, okay, can anyone else verify if it's also not clear from their end? Let me know if it's from my end or that's from Eric's end. Can anyone else verify if it is not clear from their end? Okay, nobody's responding. Then I believe it should be clear then. Since nobody's responding. So just gonna copy and paste the errors back. It's not back, so that's no longer it's not clear. So guys, how about now? Is it better? I just switched. Let's update the configuration. Is it better now? Okay, you can just let me know in the message box if it is still the same or it is better now. Yes. Yes. Okay, no, this is 0 and 9. That's not my type. Okay, please. I think it's from your hand because Emmanuel can see VS Code screen. He said it's better. Maybe you can check your internet connection. So let's do this. Open calculator of Cairo. Let me see if there's anything missing. Else, so I'm just gonna build this real quick. Think I have I think I have an older version of SN4 installed, so let me just upgrade it real quick. Okay, so this, okay, noted. So this is gonna take some time, so we are just gonna wait for it to complete. Okay, so code space, which is supposed to be the main tool, the main infrastructure to be used for this class, is having a problem at the moment. So what I think we'll do is, instead of waiting for code space, I think we are approaching. Okay, we are approaching. I mean, we are approaching the end of the time scheduled for this class. So while we hopefully wait that code space comes up, I'm just going to explain my notes. I'm just going to explain my notes. You see how that goes toward the end of the class. So we've done all of these steps. Let me just zoom in. Okay, so I talked about unit tests in the last class. So this is like building upon what we talked about in the last class. So over here, unit tests the standalone functions in a smart contract, and test functions should be in the same file as the functions being tested. So what this is saying is you can also have unit tests in your Starknet Foundry project. Right, just like this calculator contract, we can have unit tests written in here. And just use the CFG attribute. You can simply use the CFG configuration annotation, and use it to distinguish functions, modules, contract modules from tests. So yeah, we can also write unit tests in our Starknet Foundry project. And in case you're wondering, these are the places that SM Forge Starknet Foundry collect tests from, right? Because when you check our folder structure, you can see that we have a folder called test, and inside we have a file named test contract of Cairo. And if you notice, if you look at what we have, right, you will notice that we did not include the CFG, the configuration annotation that we used to group our test functions yesterday. We didn't do that today. This is because SM4 will collect tests, right, that are written in files inside the test directory. So that's why we didn't need to add the CFG annotation. And secondly, any files reachable from the package root. So I have a link here that you can check to learn more about our SM Forge collect test. And another thing you should also know about integration, you should also know this about integration test, that they interact with your contracts. You're testing the interaction of your contract with the blockchain state and other contracts. Now, when we were deploying our contract, you can see that we used this array exactly like this. This is where we used it. And this is what it means. It means that we are serializing the constructor with SAD. So that is what the array means. And now, save dispatcher, right? If you look at the test we wrote here, we are only using the dispatcher. But there is a save dispatcher variant, right? Like for counter. Now, this is what it will look like. Okay, this is what it will look like. So these two guy, and these two guy, they both perform similar functionality, but for eye counter, you can actually now when you use eye. Okay, this is the eye counter suit dispatcher. Mhm. So when you use a safe dispatcher, right? Now, Starknet Foundry will not automatically unwrap the value, the result for you. You will have to unwrap it yourself and undo whatever errors therein. So that is the difference between using dispatcher and safe dispatcher. So there's an info message. Okay, let me do that. I'm gonna save this. So before I send this, let me just make it publicly available to everyone. Read everyone to share the link. So you now have access to the notes. So that is it about Save Dispatcher. But let me explain. Let me add more notes to dispatcher and Save Dispatcher trade. But before then, this particular line that deploys the contract, this is what it means. It means it returns the address of the deploy contract and the serialized return value of the constructor. So we are not bothered about the serialized return value of the constructor. The only business we have here is the contract address. This is very important, right, in understanding dispatcher and save dispatcher trade. So now, contract interfaces, right, like this interface we have here. iCounter is an example of a contract interface. Now, contract interface defines the structure and behavior of a contract. I said that earlier on. The server, the contract public API. So if your contract needs to interact with other contract, it is your interface that will give the interacting contract the necessary exposure to your own contract. And each time a contract interface is defined, two dispatchers are automatically created and exported by the compiler. So immediately we created the iDispatcher interface. Two dispatchers were created, which is what we were trying to import here. This dispatcher and dispatcher traits. And the library dispatcher, yeah, the contract dispatcher and the library dispatcher as well. So now the contract dispatchers, right, I used to call functions from other contract. Why the library dispatchers are stateless? They are like delegate call. If you've written Solidity, they're like delegate call in Solidity. So we were supposed to talk about this from the test, but we couldn't complete the test. And even this as well. But this is just the general knowledge that we all should know. But I'm not going to go through this because we couldn't explore it in the class and we are out of time. So before we bring the class to an end, there is a very important aspect of testing in Starknet Foundry, which is using cheat code. So this is the cheat code reference. Yeah, cheat code reference. So anything you need to know about cheat code, let me share the link. But before anything, just know that cheat codes are like, now let's say you want to call a contract. You know, the test environment is different from the mainnet, right? Let's say you want to call now in this environment we are interacting with any wallet. That doesn't mean this is a DApp. I can just simply connect my wallet and I can simply connect my wallet and use my private key to send transactions, but there's no private key here, there's no account, it's just isolated. And in order for the system to work, there need to be methods need to be set in place, right, that can allow developers to perform interactions with their contract, interactions that they've been doing in their mainnet or testnet. So provision should be made to be able to do that locally. So that is where pranking comes in, right? In this case, it's called cheat code. It was called prank, but it is called cheat code. Now, let me explain one very important cheat code, cheat caller address. So let's say, for instance, calling this increase count function, we restrict it to be called by the owner only. We'll go to this calculator and we add owner stuffs. If amount is not equals to 0, but let's add something else. Let's say so this we need to import this function from Starknet. And aside. So we want to verify that caller is equals to owner. So let's quickly create an error for that. Let's call it we're just going to use not owner. And of course, we have to get the owner. First, yeah, let's say we want to restrict this function to be called by only the owner. We added an assertion there. This particular scenario, the test can only pass when you simulate the owner's address, because now when deploying this contract, we are using this particular owner address. So you have to simulate calling this contract with its owner address, and that is where pranking comes in. I hope and simply see before we call increase count. Let's say start. Okay, sorry. Start. start sheet caller address. So passing the contract address and the caller address. So this is what it's going to look like, right? And what is happening here is calling increase count function. The message to sender in this case will be whichever address we added here. So in this case, means we are calling message or sender with the owner address. So this is how to use cheat codes in your Starknet boundary tests. So I think we've exhausted the allocated time for this. Yeah, exactly. That is why I was actually confusing it with prank. And actually, the previous version of Starknet Foundry actually called it prank. I mean, you see start prank, stop prank. But the most recent version, which is what we are seeing at the moment, is they changed the name to cheat codes. Okay, so I'm not gonna waste any more time because I'm not gonna use any, sorry, not waste. I'm not gonna use any more time because we've already exhausted the time for this session. So if you have any questions before we call it a day, if you have any questions or you have any confusion or anything you want me to explain right before leaving the call, you can let me know. So I'm really gonna hang around for the next 6 minutes from now to 10:40. This is my time. This is this is 10:34. So I'm just gonna hang around till 10:40 and you indicate if you have any question. Okay, I have answered this question. Yes, it is like banking solidity. Okay, there is a question here. Uzubechi, can we also write tests for internal implementations or component? Definitely. You can write tests for internal implementation or components. And let me show you the part of the documentation that explains how you can write tests for internal implementation. Because we are limited by time, we won't be able to cover all of this aspect. I mean, that is why the documentation is here in order for you to deep dive into some of this stuff, but this is it. So as you can see here, these are private functions. They are not public, and you can see that tests are written for them. So this is how you can test internal implementation.
We can't see your screen.
Can you come again? I didn't get you.
I can't see your screen.
Oh my, oh my, oh, I'm sorry for that. I thought I was sharing my screen, but turns out I wasn't. But I believe you guys can see it now. Because can you? Okay, perfect. So this is it. If you go to the Starknet Foundry, I'll just share this in the so much. I'm gonna share this in the message box. So this is the part of the documentation that guides you on how to test internal functions. This is an internal function. These are all internal functions, right? And as you can see, tests. They've been able to write tests for these internal functions. So yeah, of course, you can do it, and this is the part of the guide that covers how you can do it. Okay, so with 10 minutes has elapsed, and in the absence of any more questions, we're going to call this a day. So thank you to everyone that attended, and thank you for your time, and thank you for also having me here. If you have any questions or need any help with Starknet Foundry or testing, you can always let me know. You can reach me on Twitter. You can reach me on Twitter. Twitter. So yeah, you can reach me on Twitter using twitter.com/prince_IBS. So that is my Twitter profile. If you have any problem or challenges, you can reach me via Twitter. Or you can also reach me via Telegram. So yeah, thank you guys and have a good night.